audience. Welcome to Gagan Online Academy, KADAPA. In today's class, we will learn all key concepts, important formulas, and public exam expected questions from MOIVRE'S theorem for Inter-Maths 2A. To solve questions on MOIVRE'S theorem, we must know polar form. Polar form of a complex number, or we call it mod amplitude form. Mod amplitude form. That is, for any complex number, z is equal to a plus ib. For this polar form or mod amplitude form, z is equal to r of cos theta plus I sin theta. This equation is called polar form or mod amplitude form of a complex number. Here R is magnitude of the complex number, and it can be found using a square plus b square formula, and theta is tan inverse b by a. This is amplitude. Now, statement of MOIVRE'S theorem. We know complex number is in the form of a plus ib. Now, I am writing polar form or mod amplitude form. That is, z is equal to r into r of cos theta plus I sin theta. Statement of MOIVRE'S theorem. We know complex number is a plus ib form. The same can be written in polar form as z is equal to r of cos theta plus I sin theta. If z is equal to r of cos theta plus I sin theta, then z power n is equal to right here r cos theta plus I sin theta whole to the power of n. This becomes r to the power of n into cos theta, right? Cos, here write this power n, cos n theta plus I sin after write this power n theta. So this is MOIVRE'S theorem. We can apply to any large number, any power, right? That is the use of MOIVRE'S theorem. If you know one complex number, you can find z power 7, z power 10 or z power 100 also easily with this concept. Z power n is equal to r to the power of n into cos n theta plus I sin n theta. Just we write this power on r and after cos and after sin n theta and cos n theta. This is the heart of this chapter. To solve this question, just recall these things. First, complex number is in the form of a plus ib. Then its polar form is r of cos theta plus I sin theta. Then z power n is equal to r power n into cos n theta plus I sin theta. R is equal to square root of a square plus b square. And theta is equal to tan inverse b by a. So first remember these things in your mind. Now start with complex number. Question is, if n is a positive integer, then show that 1 plus I whole to the power of 2n plus 1 minus I 2 power n, that is equal to 2 to the power of n plus 1 into cos n pi by 2. First observe the inside bracket. So inside the bracket we have 1 plus I. So this is complex number. For this we have to write polar form. To find polar form, right, first we have to find r value, that is square root of a square plus b square. A square plus b square. A is 1. Okay, this is a plus b is coefficient of I, that is 1. Coefficient of I is 1. So 1 square. That is 1 square plus 1 square, 2. So root 2. R value is root 2. Reason is it is in the form of a plus bi. So a value is 1 and coefficient of I is 1. So b value is 1. Substitute in this, you will get magnitude. R is magnitude. We symbolically represent as modulus of z also. Now theta. Theta is equal to tan inverse b by a. Tan inverse b by a. So that is tan inverse b. B value is 1. A value is 1. That is equal to tan inverse 1 by 1. That is 1 only. Tan inverse 1 is written as tan pi by 4. Tan pi by 4 value is 1. So I am writing here tan pi by 4. Tan inverse tan gets cancelled. We left with pi by 4. So theta value is pi by 4. This is called argument or amplitude. So theta is pi by 4. Now we know r is equal to root 2 and theta is equal to pi by 4. So first we have to find r value and theta value. R is magnitude and theta is argument or amplitude. Okay. Now for this complex number I plus 1 plus I. This is complex number. For this we are writing polar form. Right? Polar form is what? R into cos theta plus I sin theta. Okay. Now R value is root 2. Cos theta is pi by 4 plus I sin theta is pi by 4. This root 2 into cos pi by 4 plus I sin pi by 4 is polar form of this 1 plus I complex number. Polar mod amplitude form also. We call it mod amplitude form of 1 plus I is equal to root 2 into cos pi by 4 plus I sin pi by 4. So first we have to find mod amplitude form of complex number 1 plus I. Okay. After that we apply this power 2n. Okay. So 1 plus I is equal to root 2 of cos pi by 4 plus I sin pi by 4. Now in problem it is given 1 plus I whole to the power of 2n. This value we have to find. Now root 2 cos pi by 4 plus I sin pi by 4n. Pi by 4. To this we have to put power 2n. Okay. See 1 plus I value this one. Here I am writing power 2n. This side also 2n. Next, give this power to all the elements inside the bracket. So root 2 whole to the power of 2n. Root 2 whole to the power of 2n. Next, this power you can write after cos. Cos 2n. Next, pi by 4 plus I sin after write this power 2n. 2n into pi by 4. That is from de Moivre's theorem. Right? Now, root 2 whole to the power of 2n. 2 root can be written as 2 power 1 by 2 into this 2n. 2 gets cancelled, we get 2 power n. So by after simplifying we get 2 power n. Here cos 2 1s 2 2s n pi by 2 plus here also 2 1s 2 2s I sin n pi by 2. I sin n pi by 2. This is 1 plus I whole to the power of 2n. Similarly, we have to find 1 minus I whole to the power of 2n value. It is just a conjugate of this one. So write 2 to the power of n same cos n pi by 2. Just write here minus. In the place of plus, write minus I sin n pi by 2. Now we have to add these two values. We know 1 plus I 2 power 1 plus I whole to the power of 2n value, that is 2 power n into cos n pi by 2 plus I sin n pi by 2 plus I minus 1 minus I whole to the power of 2n. That is 2 power n of cos n pi by 2 minus I sin n pi by 2. These two results we have to add. Now 2n, here also 2n. So I am taking 2 to the power of n as common. Now we write terms inside the bracket. Cos n pi by 2 plus I sin n pi by 2 plus next we have cos n pi by 2 minus I sin n pi by 2 plus I sin n pi by 2 minus I sin n pi by 2 gets cancelled. So we left 2 power n. Here cos n pi by 2, here cos n pi by 2. So how many cos n pi by 2s are there? 2. So we write 2 cos n pi by 2. Don't cancel this 2 and this 2, right? This is angle, not a multiple. So multiply this 2 into 2 power n into 2. 2 power n into 2. So put 1 here. Bases are same. Powers must be added. N plus 1. Right? N plus 1. A power m into a power n is a power n plus 1. So next step will be 2 power n plus 1. Write this cos n pi by 2. This we have to show. So we show it. So in this way you have to solve problems from MOIVRE'S theorem. If alpha and beta are roots of equation x square minus 2x plus 4 is equal to 0, then show that alpha to the power of n plus beta to the power of n is equal to 2 to the power of n plus 1 into cos of n pi by 3. Right? Remember the process to solve this question. First, you have to solve the quadratic equation. So find the roots. Next, write polar form of the equations or of the roots. Then apply MOIVRE'S theorem. Finally, simplify. So these are the steps we have to remember. So first let us find solutions for this equation. X square minus 2x plus 4 is equal to 0. Using minus b plus or minus square root of b square minus 4ac by 2a, we find roots. Okay, this is x is equal to coefficient of x square, that is a value, a is equal to 1. B is coefficient of x, that is minus 2. C is constant 4 plus 4. Okay. Substitute these values. Minus b is minus 2 plus or minus square root of b square means minus 2 whole square minus 4. A value is 1 and c value is 4. By 2a, 2 into a is 1. From this minus into minus plus 2 plus or minus 2 to the 4 minus 4 4 is 16 by 2. Then we have 2 plus or minus 4 minus 16, that is minus 12 by 12. So 2 plus or minus, this can be written as 4 into minus 3 by root 2, only 2. 2 plus or minus, square root of 4 is 2. Inside we have minus root 3. So this minus root 3 we can write as root 3i. So I am writing here root 3i by 2. From this 2 is taken as common. If 2 is taken common, we left with 1 plus 2, 1 plus or minus 2 is taken common. So root 3i by 2, this 2 gets cancelled. We left with 1 plus or minus root 3i. That means 1 plus root 3i, 1 root, that is alpha. Beta is 1 minus root 3i. So first we have to find roots. These are complex roots. Now for this alpha and beta, we have to find polar form. Now we got alpha and beta values. These are roots of this equation, x square minus 2s plus 4. Now mod amplitude form we have to write. mod amplitude form of 1 plus root 3i we have to find. So this is one complex number. So to find a mod amplitude form, first mod. So how we find mod? That is R value. Okay, square root of a square plus b square. This is a. A is 1. So 1 square plus b is root 3. Root 3 whole square. Right? Then 1 square 1. Square this root gets cancelled 3. 1 plus 3 4. Square root of 4 is 2. So R value is 2. Now theta. This is called argument. Okay. Theta is tan inverse b by a. B is root 3 by a is 1. Root 3 by 1 is root 3 only. Tan inverse root 3. This root 3 we have to write in trigonometric ratio. So that is equal to tan 60. 60 ingredients pi by 3. So we write tan inverse root 3 is written as tan pi by 6. Pi by 3. Okay, 60 degrees pi by 3. So tan inverse tan gets cancelled. Finally we left theta is equal to pi by 3. So we know R and theta value. Now we write this mod amplitude form R cos theta, mod amplitude form, that is R of cos theta plus I sin theta. So R is 2 into cos theta. Cos theta is pi by 3 plus I sin theta is again pi by 3. Okay, this is mod amplitude form of 1 plus root 3a. Now take this part. We have to show alpha power n plus beta to the power of n is equal to 2 to the power of n plus 1 into cos n pi by 3. So we take a alpha power n value we have to find. So this is alpha, right? This root is alpha. So this alpha value is r into 2 into cos pi by 3 plus I sin pi by 3. Now we have to find alpha to the power of n, right? Now 2 into cos pi by 3 plus I sin pi by 3 whole to the power of n we have to write here. Now alpha to the power of n is equal to, see here, give this power to this, all the terms which are inside the bracket, 2 to the power of n, 2 to the power of n of cos, right, cos, write this power n here, it becomes cos n pi by 3 plus I sin after write this power n, so here n sin n pi by 3. So alpha to the power of n we got. Now beta to the power of n, beta to the power of n, right, 2 power n into cos n pi by 3. Here write minus because alpha and beta are conjugate roots. One is 1 plus root 3 and another is 1 minus root 3. So these are conjugate complex numbers. So just write minus I sin n pi by 3. Now here alpha to the power of n plus beta to the power of n to be added. Now we will add both of them. Alpha to the power of n plus beta to the power of n. This value we have to calculate. So alpha to the power of n is 2 power n of cos n pi by 3 plus I sin n pi by 3 plus beta to the power of n, that is 2 power n of cos n pi by 3 minus I sin n pi by 3. So here 2 power n is taken common, 2 power n is taken common, cos n pi by 3 plus I sin n pi by 3 plus 2 power n is taken outside. So now we have cos n pi by 3 minus I sin n pi by 3. plus I sin n pi by 3 minus I sin n pi by 3 gets cancelled. Now we have outside of the bracket we have 2n. Inside we have cos n pi by 3 cos n pi by 3. That means 2 cos n pi by 3. How many n pi by 3s are there? 2. That's why here 2 is there. Now 2 power n into 2. 2 power n into this 2. 2 power n into 2. That becomes 2 power n plus 1. Reason is here 1. Bases are same, power should be added. A power m into a power n is equal to a power n plus n. So I am writing 2 power n plus 1 into cos n pi by 3. Okay, this is the required result. If 1 comma omega square are cube roots of unity, find 1 minus omega plus omega square whole to the power of 5 plus 1 plus omega minus omega square whole to the power of 5. So to solve this question, you must remember these two results. 1 plus omega square, that is equal to 0, and omega cube value is 1. Remember this, you have to apply while solving this question. Now given question is 1 minus omega plus omega square whole to the power of 5 plus 1 plus omega minus omega square whole to the power of 5. Solution starts from here. Now from this 1 plus omega square, 1 plus omega square, right? Send this plus w, it becomes minus omega. So in the place of 1 plus omega square, we write minus omega. See here 1 minus omega plus omega square whole to the power of 5 plus 1 plus omega minus omega square whole to the power of 5. Use these expressions. 1 plus omega square, from this 1 plus omega square is equal to 0. 1 plus omega square is equal to, right, it will become minus omega. So here 1 plus omega square, I can write minus omega. Here already 1 minus omega is present. So I can write like this. Then plus 1 plus omega. See, from this 1 plus omega is equal to minus omega square. So in the place of 1 plus omega, I can write minus omega square. Here one more minus omega square is present, whole to the power of 5. Next step, minus omega, that will become minus 2 omega whole to the power of 5 plus minus omega square, it will become minus 2 omega square whole to the power of 5. From this minus 2 power 5 common. So minus 2 power 5 is taken common. We left with omega power 5. Again here omega to the power of 2 5 are 10. 2 5 are 10 here. Then minus 2 to the power of 5, omega 5 plus omega 10. Now we left with omega to the power of 5 and plus omega to the power of 10. Use this, omega cube is equal to 1. So now omega to the power of 5 can be written as omega cube into omega square plus omega 10 can be written as omega 9 into omega 1, right? 9 plus 1, 10. Next, minus to the power of 5. This omega cube I am writing as this, and omega square plus omega cube 9 I am writing omega cube whole square, whole cube, 3 3 are 9 into omega to the power of 1. Next, minus 2 to the power of 5. Omega cube value we know 1. Omega cube is 1. So 1 into omega square, that is omega square plus omega cube is 1. 1 cube is 1. 1 into omega. Again minus 2 to the power of 5. Omega square plus omega. See here omega square plus omega is equal to minus 1. So here write minus 1. So minus into minus plus 2 to the power of 5 2 to the power of 5. 2 to the power of 5 is 32. So final value is 32.